Yo, Chuck.
Hey, what's going on YouTube? In this video, we're going to go over cocktail sort, which is an adaptation of bubble sort. It's a little bit faster and more optimized. As always, I'm going to explain the algorithm with visuals so you really know what's going on behind the scenes. And then finally, we're going to code it out. So this should be a fun video. Let's get started. So here we have our data set, and you'll notice that it is unsorted. We have larger numbers at the beginning, and we want to have those larger numbers pushed to the very end. So cocktail sort is just like bubble sort in the sense that it's going to compare adjacent items. So recall from the bubble sort video, we're comparing adjacent items. If the item on the left is greater than the item on the right, we perform a swap. We continue this process until we reach the end of the array. And this is where cocktail sort differs from bubble sort. So bubble sort just has you do left to right, those comparisons, like 5 times in this instance. So like 1 time for every element of your list or array. What the optimization of cocktail sort is once you perform that initial left to right scan through and you reach the very end of the array or list or data structure you're storing these items in, now you're going to do the reverse and actually compare adjacent items backwards, and then again you're pushing the highest values to the right. So it's a little bit faster and more refined than bubble sort. So let me show you a couple of iterations of how this would look as we're looping. So I'm going to copy this data set, paste it here. Notice I have a start index and an end index. So I want to show where the starting point is for your initial index and then your end index. These are just the starting points, okay? So our first iteration from left to right, we're going to start at 0, index 0, and then we're going to end at the second to last element. Now, why am I ending at the second to last element? Because I'm going to make those adjacent comparisons, right? And then I don't need to technically go to 2, because if I went to 2, I would make a comparison between 2 and undefined, which doesn't make any sense. So I can actually make the starting point of my end index right here. Okay, so now that we've established that, let's perform our left to right comparison. So I say, is 5 greater than 1? Yes, it is. We perform a swap. Is 5 greater than 4? Yes, it is. We perform another swap. Is 5 greater than 3? Yes, it is. We perform a swap. And is 5 greater than 2? Yes, it is. We perform a swap. So that is our left to right iteration. And notice, whenever you do one iteration, this array may not be completely ordered, but the thing that you'll always have is the greatest value will be at the very end. And that's important to remember, okay? So the greatest value, we know for a fact, is now at the very end and in the correct position. Okay, so that was our left to right. I might even annotate that, left to right, just to make sure. Okay, let's do the same thing again, but like I said, we're doing cocktail sort. So now we're going to go right to left. But before we do this, we need to update our indices. So I'm going to remove the 2 as the start point of that end indices, and I'm going to update it to 3. Because recall, 5 is the greatest number in the array and in the correct position. Therefore, we don't need to compare 2 and 5. We just need to compare 3 and 2, then 4 and 3, then 1 and 4, etc., etc. So let's do that right now. So is 3 greater than 2? Yes, it is. And then is 4 greater than 2? Yes, it is. Make the swap. And is 2 greater than 1? Or is 1 greater than 2, I should say? No, so we stop in that iteration. So that's the right to left iteration. So let's copy this data. I think we'll be sorted in one more iteration or so. Let's copy, we're going to do another left to right, okay? So now that we've reached this point, and we've completed this right to left looping of our data, we can actually update our starting indices one more time. So I'm going to do that. Come in here, reset this, and then that. Okay, so now we're starting here, and this is pretty easy. We're starting, and our ending indices is actually going to be still right here, right? Because we're just going to compare these two. So we start at 2, compare it to 4. Is 2 less than 4? Yes, it is. So we need to leave it where it is. And then we go to our very last indices. Is 4 greater than 3? Yes, it is. So we're going to swap right there. And at this point, the loop is completely, or the data is completely sorted, and we would just exit out of the program. So you can see how it kind of moves like a windshield wiper almost. Like you scan the data left to right, then you do right to left, then you do left to right. And every iteration of these loops, you're adjusting your starting and ending index values. And this will make the algorithm very efficient compared to bubble sort, for instance. So that is the visual explanation. Now let's hop over to the code. All right, so for coding out cocktail sort, first thing we're going to do is come in here and just make a function called cocktail, have it take a parameter of array, and let's just return that array for now. So let's console.log out the function call of cocktail. I'll pass in the array we used during the visualization of 5, 1, 4, 3, 2. Okay, I'm going to clear my console here. And let's run this code. You can see it's just returning the array. Okay. So if you recall from the previous talk on the visualizations, we have a start and an end index we need to update. So we're going to say let start initially be set to 0 and let end equal array.length minus 1. So that is going to make the end index actually this 2 value, okay? And then the start obviously would be the 5. Next, we need to have a condition to break out of our loop if no swaps occur. So the way we're going to do that is just make a variable called swapped. I'm not going to give it a value initially. The cool thing about cocktail sort is we're going to implement a do while loop to actually do this. So I'm going to say do a block of code while the condition is swapped. So if a swap happens, we're going to continuously run this loop. If there is no swaps happening, it's going to break us out, and I'll implement that code in just a second. But recall, a do while loop always executes at least once. So that is why we're using this code, because we want to make sure we at least execute once, because we can do a scan of the numbers. If no swaps occur, then we know it's already sorted. So initially, we're going to set swap equal to false. And then we're going to perform, just like our bubble sort, we're going to perform a left to right comparison of adjacent numbers, just like this, until we reach the end. So I'm going to come in here and make a for loop. I will set I initially to the start indices. Then, as long as I is less than end, we're going to increment I. So because I is the last element based on this variable right here, by going until I is less than end, we're actually going to stop when I equals this 3 right here, or array at index I equals 3, and we're going to make that comparison of 3 and 2, for instance. Okay, so let's make those comparisons. So I'll say if array at I is greater than array at I plus 1, we need to perform our swap. I'm going to store the value of array at index I. Whoops. I'm storing the temporary value of array at index I, and now I'm swapping array at index I with array at index I plus 1. And I'm doing the same thing for array at index I plus 1, but I'm setting it to the temporary variable we just stored. That performs the swap, and now I need to alert the swapped variable that we've actually committed a swap, okay? So don't kick us out just yet. Keep going. So I'm going to say swapped equal true. Okay, now that we've performed our left to right comparisons, it's time to update our indices. So I'm going to say end minus minus. But also before the end right here, I want to do a break statement. So I'll say if swapped is not true, if we never swapped anything, then I know the array is already sorted. So let's just break out. And this will save us a lot of resources. Okay, so then after that, we're decrementing the end index because we know the value on the far right is always going to be the greatest. So after the first iteration, 5 should be on the end because it bubbles up to the right-hand side. So we can actually do that. Let's just return the array at this point. And you can see when I'm saying 5 has bubbled from the initial starting point of the 0 index to the 4th index, right? Okay, so now that I've proven that, let's do the cocktail sort specific right to left comparisons now. So we've decremented our end index, so it's right here now. Let's go make another for loop. I'm going to set the I index to end minus 1. You might be like, why are you setting it to end minus 1? You already decremented it here. Well, recall, 5 is at the very last position. End is right here. If I do end minus 1, I'm actually starting right here. And now I can compare these two values. And that is the most efficient way to do it. So I don't need to compare 3 and where 5 is because I already know 5 is in the correct position. Okay, so in the for loop, I'm also going to say while I is greater than or equal to start to have a place to stop, and then I'm just going to decrement I. And then it's the same logic as before because we're doing side-by-side comparisons. We're just doing it from right to left now instead of left to right. So I could actually copy and paste this code. I don't recommend doing this because you don't want to repeat yourself whenever you're coding. But for educational purposes now, we can just leave it the way it is. Just so you can kind of see we're performing those swaps still. And then after we perform that right and left comparison, we need to update now our start indices. So just like the visualization explained, I'm going to update start. Just like that. And that's pretty much it. It's just like a windshield wiper going back and forth, and then your array should be sorted. Let's return the array to just make sure it worked. And you can see it did work. Our array is sorted. For educational purposes, I want to see exactly what iteration this loop breaks out of. So I'm going to come into my statement here and say console.log start. I want to see what our start indices is at. So it looks like when start is equal to 2, this would be fixed. Now, what's going to happen if I have a sorted array? What do you think is going to happen here? What indices of start do you think it's going to kick us out at? 0, right? Because it's going to do that initial scan and be like, hey, this is already sorted. I don't need to make any swaps. So swapped is going to be false. It's never going to be set to true. Therefore, we're going to get kicked out. Let's do a non-optimal case. So an array that's completely unsorted. Let's see what happens now. What do you think is going to happen? It looks like it takes 2 iterations to completely sort this array, or 2, because you're incrementing start twice, which would be a little bit faster actually than bubble sort, because with bubble sort you'd at least have to do it probably like 4 times, I believe, or the indices would be set to at least 4. So this is a little bit faster than bubble sort. So one more thing I want to show you, if you didn't watch my other videos, this code is bad because we're just repeating yourself. There's a saying in programming, don't repeat yourself. So let's just make a function that's going to perform this swapping without this huge block of code. So I'll make a function called swap. It's going to take an array as a parameter, index 1 and index 2. And it's just going to do the exact same code we have here. So we'll say array at index 1. Actually, let's make our temp variable. So we'll say let temp equal the initial value of array at index 1. Then I'll set array at index 1 equals array at index 2. And then finally, array at index 2 equals that temp variable. So I can come in here and delete this code and just put in our swap function call, pass in the array, and then what do we need to pass in for our indices? We need to pass in I and I plus 1. Okay, and I'm going to do the same thing for this other one up here. And let's make sure this works. I'm going to delete this console statement. I just want to make sure we're still sorting. Okay. Well, we got an error. Oh, I spelled something wrong. Okay. Let's try it again. And there you have it. It's still working. Let's throw in some crazy values. Try to break it. Looks good. Okay, so there you have it. That is cocktail sort. You can see it's a little bit faster and more optimized than bubble sort, but it's very similar logic. Just remember that swapped statement is going to be critical for kicking us out when we don't need to perform any more swaps. And it just works just like a windshield wiper. So I hope you guys enjoyed this video. I will see you in the next one.